our Docker studies. We are going to look at Docker volumes today. Yesterday we took a look at Docker Compose. We took a look at Docker Compose and we saw what Docker Compose was. We had some examples with Docker Compose, and today we are going to continue with Docker volumes. We want to see what volumes are in Docker and how do we use them. So don't mind that we did not do enough with Docker Compose. There is a lot as we are going ahead. Every examples that we are going to be doing, most of it we are going to be using Docker Compose. So as I did tell you yesterday, Docker Compose is what is used in the industry, not -- link. So today we are going to be looking at Docker volumes. So why Docker volumes? Why should we use Docker volumes? Yeah, the tendency is that there are some containers that process information, and when they process that information, they need to store that information somewhere. Okay, there are some containers that are running. They are simply applications that are running, and as they are running like that, they need to process data and then store the data somewhere. We take an example, like you can create your school management system and make it a Docker container, a Docker image. That school management system will have to be running information and keeping it in a particular volume or in a particular database, right? So that it can be reused again. So how to create volumes in Docker is important for you to know how, if you have that type of a situation, you might create a volume for that data to be stored inside. So we are going to see different types of volumes. We have simple volumes. What is a simple volume? A simple volume is just a volume that is attached to one container. When you talk about a simple volume, we are talking about a volume that is attached to one container. And then we are going to have shareable volumes. Shareable volumes are volumes that so many containers are sending data into that particular volume. So many containers are sending data into that particular volume. Okay, and then you have to also understand the concept of containers not being that's containers being ephemeral. That is, they die at any moment. Your container can get destroyed at any time, and then you kill the container and then you start up a new container. What if your container gets destroyed when you are processing some good information, or when that container is containing some good data and the container get killed? If that container get killed, at least that information must have been put into a volume. And information put into a volume, the container can die. When the container dies, that volume is there. That volume is available there. You can use what we call the mount path. The mount path to get to that particular volume. So here we are going to see how to create volumes in containers, destroy the containers, and then use mount path to get to those volumes. And then we see how we can make volumes shareable. Okay, that is our plan for today. So with your notes that I have here, we are going to be looking at Docker volumes. So the first thing we want to do is move into our system. Our system was not yet ready. So we call them reusable volumes. Docker volumes are reusable volume. The volume used by container can be shared with other containers. Even if all containers are deleted, data will still be available on the Docker host. Okay, what is a Docker host? The Docker host is your machine, a machine where Docker is running. Okay, so in order to create a volume, what is the procedure? First thing that you do is you create a directory. Okay, you create a directory. And how do you create a directory? You just run make dir. The directory is called data. That is a directory in your computer. It is called data. So you run make dir data. That directory gets created. Okay, then now we'll start a volume. For example, I took the CentOS image. We'll start the volume. We'll start a container, and we are going to run this container C1 and attach this volume. This is the first thing that we are seeing today in this command. We are running the container C1, and then we are going to pass an attachment to that container. So the question in an interview session is, what do you do when you want to pass a volume in a Docker container using the command line? You answer, you use -v, and then you pass / the volume that you have created. Okay, -v is what you use in order to pass a volume in the container. Now, in the case of Docker Compose, what will you do? Volume will be another step. Okay, you will come and you will say volumes, and then you will mount this your volume. We will see that. Okay, then now when you create this container, the container will be running. Okay, your container will be running, and when the container will be running, you can go into the Docker volume, and then you currently see no files. You create files in the Docker volume, and then you destroy the image. When we destroy the image, the container, please, not the image, the container. When we destroy the container, we are going to the image, the volume that we have added to that container is going to remain permanent, right? Now, after you must have destroyed that container, you can start another container. Okay, you can start another container. Now, in this time when you are starting another container, what can you do? You can start another container, and when you start another container, you can attach that particular volume that was in the first container to the second container. Okay, from this one, you pass this command -- volumes from the name of your first container. Okay, that means this container will use the volume from the very first container. Okay, so let us try to see how the two of them are functioning, and then we try to see how we can use them for our purposes. Okay, then we'll see what is a mount path. Okay, we'll see what a mount path is. Okay, all right, let us, yes, Declan.
CentOS, what is CentOS? I can see the image CentOS.
Yes, the CentOS is an image, right?
Yes, sir.
You want to ask what it does or what it is used for?
Functionality, yes. That is useful, sir.
CentOS is an operating system now.
Okay.
When you want, just go to Docker Hub, and when you see any image and you don't know what that image does, just go to Docker Hub and you read about the image. What is CentOS? What does CentOS do, and all the like.
Okay.
Yes.
Okay.
When you or you just go to Google, right? You just go to Google and you say, what is CentOS? Focus around goal of providing a rich-based platform for open source communities to build. That means CentOS. CentOS is that is some sort of an operating, a mimicking operating system software. Okay.
Okay, sir.
All right. All right, the first thing we are going to do is we want to create this is the first thing we want to do. What is this command saying? We are creating a directory. Okay, when I do that,
You need to run sudo.
pardon?
Do you need to run sudo there, sir?
Of course, permission is denied. They say when permission is denied, you run sudo. Sudo is coup d'etat. You take it by
Like
force.
Marcelo Gabon. Marcelo Gabon, yeah.
Sudo is coup d'etat. You take it by force. Okay. Now we have in our system we should be having a directory created called data. So let us cd into data. So we are into data, right? That is a directory that has been created called data. So if we run ls in data, there is nothing in data. Okay, that means we have created a directory. That directory is called data. We are going to use this directory that is called data as a volume. Okay, what is a directory? A directory is just a simple folder. Not so. It is like a folder in Windows. So what we have done is we have created a folder, and in that folder, data is going to be kept inside that folder, so that if the container gets deleted, there will be no issues with us. Okay, so we have created the volume. The next thing is we run our CentOS. Okay, after creating that, we run our CentOS. So our container name is that. So we are running docker run --name CentOS or C1 interactive mode -v. This -v, now we are passing this volume that we have created to this container. Okay, we run the application. Technically it is not available. It will be pulling. So when we create this container and the container gets created, where shall we be found? We are going to be found inside the container, right? Why are we going to be found inside the container? Because we use interactive terminal. If we did not use interactive terminal, what could we have used there? What is the opposite of getting into the interactive terminal? Who knows the opposite of getting into the interactive terminal of CentOS? It is using the detached mode. When you use the detached mode, you do not get into the container. The container creates and everything runs, and you remain in your own terminal. You do not enter there. Okay, so that is CentOS that has been created, and CentOS has been created with that data as part of that as a volume to this operating system. So now what we are going to do is, inside this CentOS, let us create a file. If we create a file like let us just create a file like touch f1 or file1, file2, and file3. We have created 3 files, right? If we run ls, we will see file 1, file 2, file 3. Now let us go into, we are supposed to create the files in data, because when the CentOS will be off, all these files are going to be off. Let us go into cd. You see now the data that we created, it is there, right? We run into cd data, ls here, nothing is there, so we create file 1, file 2, file 3. Now run ls inside here. We can see our file 1, file 2, file 3 inside this data system here. This one. This is the volume that we have just created. So we run F1, F2, and F3 inside that volume. Okay. The next thing is that we should come out from CentOS. Yes, Declan.
So I was thinking the first files we created, they were created in the container.
Yes.
CentOS, right?
Yes.
But now, okay, you seed it into data and it was empty.
Yes.
Wasn't there a way in which you could copy those files that are present in CentOS and transfer to?
Of course, you can copy.
Data?
You can use your copy command and copy it. I wanted to
Okay,
create in
because
2 places so that you should see that when this container gets destroyed and recreated, you will not see these files, but you will see these files.
okay. Yes,
You could copy these ones and bring them back here without any problem. Okay, but when the container will get destroyed, these files will get off. You will not be able to see these files. Okay, but you will see these files down here. So we have created this one now. Okay, now if we leave exit, if we like exit this container, now we run docker container ls. Is there a container again? No, there's no container. Why is there no container? Who can answer?
so because you quitted without saving.
I quit without saving. Is that the word?
You exited. You have. I can't quite get the word, but I think you left the container. I think the command should have been control PT or
Yes, I should have. I exited and then shut down the container.
shut down Iwala. That is it. That's the thing.
Right, I exited and shut down the container. In addition to, when I run docker container ls, I cannot see, but when I run docker ps-a, what happens? I see the container, right? But is the container running? The container is not running because I exited and shut the container down. Okay, now if I decide to delete the container, what will happen? The container will be gone. So if I run back docker start this, the container starts. Am I inside the container? No. Why? How do I get into the container? Docker exec it CentOS, right? Let me use I run docker exec interactive mode. A command is not the right command. Let me take the right command, please. docker exec hyphen it interactive mode. Yeah. CentOS should be using what? What is the shell command for CentOS? Docker exec hyphen it CentOS should be using what? Bash, right? Okay, let us go with the container name. Container ID, please. Okay, now I am inside this container, right? Okay, let us run ls inside this container and make sure that the container is running. Okay, now we exit the container. We exit the container using control pcure. Okay, now we have exited the container. Let us run docker inspect. Docker inspect our container ID. Now there is something we call the mount path. Are you seeing this path? Let's look for the mount path. As a log path. As a mount label. Volume. This should be our mount path. Where you come and see mounts, right? Now you come and take this mount path and you keep. This should be your mount path. Take the mount path and we keep. Let's replace this one. Okay, that is our mount path that we have copied. Okay. Now, what can we do? We can terminate our container. Well, let's run docker container ls. Our container is running. So docker rm -f. We pass our container ID. Our container is terminated. So docker container ls. We cannot see anything. But question, what about that volume that we created that was with this container? Can we see that volume? Can we talk to that volume? Can we communicate to that volume? How can we do in order to communicate to that volume? Let us run cd and then we copy our volume and see if we can attach it and see what is inside that volume. So we had to run sudo sudo cd to that. Okay, you see that we cannot find that particular container. We cannot find that particular volume. Okay, now what do? We want to run we want to run we want to make sure that we verify and take all the information. The container is dead. We want to make sure that we verify and take all the information that is available in the container. What can really be done? That is available in the volume. What can really be done? How should we go about it? How can we really go about it to get the information that is inside our container, our volume, please? Sudo okay, now come back to where is our container volume mount path. Normally, which mount path did we use? It's like I've taken two mount paths differently and I don't know which one I actually took. Let me check something, please. Check my ball. Let me run some ball. My sudo is a privilege. Okay. Okay, you know what they were trying to tell us? They just said cd is a shell built-in command. It cannot be run directly with the sudo privilege. So the option with cd and sudo cannot run directly. So what I had to do was I ran now the command directly. I then move into administrator mode with sudo su, and then I ran the command directly, and now here I am inside the container, inside the volume. So inside this volume now I can run ls and I see those files that I created. Okay, all the files are there, but the container is deleted. The container is deleted. So if I run docker container ls, I cannot see any container. The container is deleted, but the volume persists. That's why we call them persistent volume. So you will always come out along the word persistent volumes in Docker. What are persistent volumes in Docker? Persistent volumes are volumes that are created such that the container can store information inside those volumes, such that when the container gets deleted, that volume remains with the data that that container was processing. That is what we call persistent volume. So we have seen the first type of volume, which is actually the volume that is shared by one container, right? Now let us create CentOS, and then we create another container, and then from that container, now the new container that we are creating, we use the initial volume that we had created to link to the new container. That means two containers now will be using one volume. Okay, that is the next thing that we want to do. Right up to this moment, any worry, any question? Right up to this moment, is there any question? Yes, Declan.
So at this level, the data is inside the information is inside the data you created, right?
Yes.
Then now, how can you extract this information from there and use? Must you only create another container?
Here we are inside. That is what we have just done. We have looked. That is the reason for this mount path that we were looking.
Okay.
We just looked for the mount path. We are inside the container right now. If you paste this mount path like this, you are inside the volume.
Okay.
Okay. If right now if you take this mount path, this is your mount path, right? Is it? This is your mount path. If you copy it and you cd, you discover that you are inside the volume right now. When you run ls, this is the data that we created. Are you seeing? We created file 1, file 2, and file 3.
And you can be able to execute it.
Yeah, you can remove now the data from here. You can use the data. You can, if the data was maybe log files, maybe things like let's say and a process information, you can take it from here. Maybe it was processing files, maybe it was processing particular pictures, maybe it was processing anything. They will be available here.
Okay, understand.
You will not lose them. So you always work with persistent volumes all the times. When you are mounting a container, most of the times you always mount them with persistent volumes. Okay. And you can also delete the volume. You know how to delete the volume? If you come one step behind, you run ls here, you see that data there, right? You can delete it, not so. You can run rm-r and then underscore data. You have deleted it. If you run ls again, you have not seen anything. That's gone. Okay. Now what we want to do is we want to create a CentOS container, come out from that container, create another CentOS container, and let them use one and the same volume. Let us get started and see what we want to do. Here, what we are struggling to do is we are going to create a volume and then create a container and then link this container to this volume and then create another container and then link this other container to this volume. That's what we want to do. So this container, when it is running, it is keeping its information inside this volume. This container, when it is running, it is keeping its information inside this volume. If this container dies, all the information that it was keeping is inside this volume. If this one dies, all the information is in this volume. If the two of them die, all the information is inside this volume. and we can still create another container using this particular volume. Okay, so let us go get started. Okay, we make our, first of all, make our volume, create this volume. Let us call it data1 to differentiate. Let's even call it CentOS underscore volume, so that it should make sense that that is what we have created. Okay, now look at what we have just done. When you create it, you run ls, you cannot see it. Okay, because you are creating it in a particular directory. Okay, now we have created the volume. We want now to create CentOS and link it to that volume. It is a normal command that we did, that we ran the other time. We are going to use now this time our volume is going to change. Let us do this. Okay, in this time around, our volume was CentOS underscore volume. All right, now we are going to create this CentOS. We are creating this CentOS container, and while creating this CentOS container, we are going to enter the container, and we are going to use the image CentOS and the volume that we just created up here. Make sure the spellings are the same. If you miss one spelling here, it is going to fail because it will not see anything here. So CentOS underscore volume, CentOS underscore volume. I think we are right. We launch. Okay, our image is created. Why was it created very fast? Because we already had the image after running the first command. Okay, so we are in the image. If we run ls, we will see our CentOS underscore volume here. Okay, we can enter that CentOS underscore volume. Let us enter there, and then we run ls here. There is nothing here, right? We create a file there, touch file 1, file 3, file 5, so that we use a different numeration. Okay, we run ls. We can see the files are there inside that volume. Okay, now we exit while the container is still running. Okay, what am I trying to do? Okay, now we are out. Let us see if the container truly is still running. Docker container ls. Our CentOS container is running. Okay, as it is running, we want to create another CentOS container, and this time around we want to link the first container to the second container. Let us look at the command. Here is the command. We are going to be creating a second container of CentOS, and we are going to be entering its interactive mode, and this is the information: volumes from C1. Remember that our container name here is C1. This is the name of our container, C1. So we are going to be using hyphen hyphen volumes hyphen from C1. Then we create our container from the image CentOS. The container name will be C2. Okay, we run this command. I've copied the wrong thing. Our container is created. Let us run ls here. Boom, we see what we have tried to do. This is the volume of C1. What have we done? We have created a container, two containers, and linked them to one volume. And inside this container, you can go inside that container. We will see the files that we created when we were in the first container. So if we run ls cd CentOS underscore volume, and then we run ls here, you see our files that we created. We created file 1, file 5, file 3, file 5. Now let us create touch file 10, file 20, file 30. We create these three files, right? We run ls now. We'll see that there's file 1, file 10, file 20, file 3, file 30, file 5. If you go now, let us leave this container and allow it running. pcure. We leave the container, right? The container is running. Okay. Now we want to enter the first container that we created, which was what? Docker exec hyphen it what? Let us use the container name. What was the container ID again? Docker container ls. Okay, docker exec hyphen it container 1. This is it, the first container. We enter there, and then we use bash. We are in that container. We run ls, then we run cd to our CentOS volume, and then we run ls. We'll see that the files that we created in the second container are inside this one. So the two containers, the idea is that the two containers, what we want to present as our solution is that we are able to create two containers and link them to one volume, and in such a way that if the two containers are no more there, we can still access the data that those two containers were processing. So let us delete all the two containers. But before deleting all the two containers, what do? We need to first of all run mount path, right? We need to first of all run the mount path. So let us go into C2 and take the mount path of C2, come into C1 and take the mount path of C1, right? We just run docker inspect. Then we take C1 or C2, any of them. Okay, where should be the mount path? This should be the mount path. So this mount path C2. Okay, we have taken the mount path for C2. Now docker inspect. Let's take for C1. Docker inspect C1. So this will be the mount path for C1. C1. Now we can destroy our two containers. We can destroy our two containers. Let us run docker container ls. You run docker rm-f. We pass the two containers and we destroy them. Our two containers are destroyed, so we run docker container ls. We cannot see the containers there. We run docker ps-a. The containers are not there. All right, now the next thing that we want to do is we want to verify. Let us consider these containers we are running and they happen to die. Can we get the documents that these containers we are processing? Yes, we can get them by using our mount path. We take our mount path and then we run cd, paste our mount path, and we are able to enter our volume. The volume is there. We run ls in that volume. We'll see all the files that we had here. Okay, now did you realize that whether the mount paths are the same or not? Did you take a look whether the mount paths are the same? Can we realize whether the mount paths are the same or not? We have var lib docker volumes 36490e debc, the same thing, 0c2d7784. You see, all these things are the same. If you follow all this nomenclature, everything is the same right up to here. So these two mount paths are the same. It doesn't matter whether you pass through which direction. So an interview question: for a docker container having, for two docker containers having one volume, do they have the same mount path or different mount paths? You should be able to say that they have the same mount paths. Okay, the two of them do have the same mount path. All right, so that was our idea about docker volumes today. Any problem, any question? Yes.
Yes, hi, sir. Good afternoon. Good afternoon to the class.
Good afternoon.
Unfortunately, I joined the class late, but I'm not really able to capture everything. When I will go through the video again, then so probably I will have some questions to ask.
All right. Just taking the opportunity now to answer your question. You did ask a question which the client was having a problem with it. The question was that when we were using general servers, we link Tomcat to Jenkins using the IP addresses, and Tomcat was able to communicate with Jenkins using IP addresses. Now, in the case where we want to use but Docker containers, does the hyphen link, is it sufficient to make Jenkins communicate with Tomcat? The answer is no. The answer is no. The hyphen link just permits a route. That is, you create the fact that Bamenda and Yaoundé have a road that is linking the two of them does not mean that if you leave Bamenda and you are going to Yaoundé, you will not be checked at the Matazam police station. You get the idea? They are going to check your credentials at the Matazam. Oh, let's not use Yaoundé Douala, Yaoundé because they. Let's take you are in Dubai and you left Dubai. There is a road linking Dubai and Cameroon, which is an air route. There is an airplane that is flying Dubai, Cameroon. That means there is a road linking Dubai, Cameroon. Now, but can anybody just get up and go pass, enter the plane and be going? No, of course. That person's need to pass through custom check, visa procedures, visa applications, go through a series of checks and checks and checks, and they want to know what are you going to do to Dubai before you can actually enter a plane and move to Dubai. Even when you are now even in Dubai, at the airport in Dubai, they will still do some checks to you before allowing you into the society of Dubai. That's the same thing with Jenkins and with containers, Jenkins and Tomcat. When you have just created a superhighway between Jenkins and Tomcat, but now what about the authentication? Jenkins have to authenticate to Tomcat and Tomcat has to authenticate to Jenkins. The two of them has to make sure that, yeah, I know it's you, Jenkins, yeah, I can allow you to come, and Jenkins say, yes, I know it's you, Tomcat, I can allow you to come. So the two of them have to authenticate themselves, and we did demonstrate how to authenticate Jenkins to Tomcat and how to authenticate Tomcat back to Jenkins when you run the two containers, right?
Yes, sir, yes, we did that too.
So you can do that same authentication with containers.
Okay, sir.
You can take that same authentication and do them with containers. Is that clear?
Yeah, now it's clear, sir. My doubt is clear now.
Okay, good.
Yeah.
All right. Renee, you are welcome back. Have you finished painting? Renee, are you there?
I'm there, sir. Good morning. Good morning to everybody. I'm done, sir. I'm done.
And are you going to be able to catch up?
I will try.
You should try. You should dedicate some time. Okay?
I will try. I will try.
Yes, you should dedicate a huge amount of time. And I'm always there to answer questions. I think Kiba is always there to answer questions, and Declan is always there to answer questions. So you should really dedicate some time.
The vocabulary is just too strange for me, but I will try. I will try.
The vocabulary should not be strange. You should just use Google. When you hear of anything that you don't know about, just use Google. Ask Google, what is this thing? Google will tell you. In containers, what is a container? Okay, we started doing Docker when you were not there. All right, go back. Just go through the videos, and you will get through it very easily.
Okay, sir. Thank you.
Yes. All right. That was what we had for Docker. I think for Docker volumes, please. I think with that we are finishing Docker volumes. Tomorrow we are going to be creating now our own images in Docker. Okay. Tomorrow we are going to start creating an image in Docker. Up to this moment, you are using images that have been created and you are installing and you are happy, right? You just run Docker pull and you keep pulling the images from Docker Hub. Who is creating those images? Who do you think is creating those images?
The Docker community now, sir.
And now you are part of that community.
Okay.
So right now you are part of the Docker community. You can start creating your own images and also pushing them to Docker Hub so that other people can also start using those images, right? You discover that when we use the official image of Tomcat, we were unable to visualize it in the browser. Okay, somebody like you created an adapted image of Tomcat, which is now called Tommy, that when you use, the access to the browser is very simple. Okay, so you are part of the community of Docker, and you will start learning how to create your Docker images. Actually, the reason for creating Docker images is not actually that you will be creating Docker images and pushing to Docker Hub. No, all the applications now that are going to be built are going to be Dockerized. So any application that is built in your company, you need to Dockerize that application. And Dockerizing an application means building a Docker image. Okay, Dockerizing an application is taking that application like you take a normal executable application, and then you turn it into a Docker file. You turn it into a Docker image that can now run on Docker. That is the meaning of Dockerizing an application or Dockerizing an app. Okay, so that is the next thing that we are going to do, which is building Docker images. We are going to learn there are two ways by which you can build Docker images. The first way is you can customize those images. You can take containers that are running and then you customize those containers. Second method, which is the mostly used method, is that you can write what we call a Docker file. Now, these terminologies will start confusing. We have started mark the terminologies very well. It took me a lot of time to understand these terminologies. Mark, the first terminology was Docker Compose. It is also a file. The second one is Docker file. It is also a YAML file, but it is different from Docker Compose. So you should be able to know what is a Docker Compose file, what is a Docker file. Another files are still coming up as we are going ahead. So you should be able to mark differences between those files as we are going, and don't get confused. All right.
Okay, sir.
All right. See you guys on Monday. Am I going to leave you like this without an assignment? All right. Listen. There's one thing I want you to do. Set up a CI/CD platform using Docker containers like the one you are setting up, and please run a job. Set up a CI/CD container and run a job. That is for our weekend. You set up a CI/CD container and then you run a job. Yes, Mr. Eddie.
Oh yes, so this drives me to the last question that I have for today, sir. Is the clan there? The clan?
I'm not sure the clan is there.
Okay, sir. I just wanted to
I'm
find
there.
out.
I'm there. Yeah.
Okay, the clan. I want to know how did you copy that generated password given by when we were running our discussion?
The clan actually testified to me that I taught him how to do research and not to just ask everything, and he went and did research and got it, and then you went and got stuck. I knew that is a question that I was waiting from the clan, and I told him that when I did not hear him ask that question, I was very happy because he went and did research, and that is the spirit that I want. Usually it just takes typing in YouTube that how to get the Jenkins code in Docker. Just type in the internet and that's all. You see, and there's a dedicated video. I think there are around 3 of them.
But sir, there was we had the generated password, so that is not the password.
Which one are you talking about?
In Jenkins.
Yes, the admin password is there.
Okay, but that one took so much time, and they were telling me password not correct.
You had the generated password there?
Yes, I had it there. I had it here.
The admin own.
Yes, exactly, the administrative password. So when I was running it to open my Jenkins, in order to go one step ahead to create a job, they were saying password not correct. So
declare what did you do?
So he needs to run a different command. The password was not generated. He needs to run another command to get into the logs of Jenkins.
I know
Then
that the
you see the
password is
password.
not automatically generated. And when you are saying that
Yes.
the password was automatically generated, I doubt where you saw it. Mr. Kiba, I know that the password is not automatically generated when you use containers.
So it means what I thought was that it was the password was not it, because I saw something like,
That
I'll
is
share the,
that is why
okay.
I always say that when you are placing a problem, it is good with screenshots.
Yes, I'll share the screenshot later.
Yes, it is good with screenshots, and then the client should get to you and give you the commands to run so that you can get
Jenkins.
the right command.
Okay. Okay.
Okay,
I
so
will. I
I'll
will.
do the plan. Yeah, yeah.
All right, guys. See you on Monday. I want to see your jobs running in your containers. Okay.